Okay, so as in the last video we have discussed about the wave and its type. So today we will be going to discuss about the characteristics of the wave. Alright, so the first characteristic, initially I'm going to write here what we will be discussing today. We will be discussing about the characteristics of the wave. Characteristics of waves. Alright, as I have given here the heading, so what we'll be discussing about the characteristics of the wave. Alright, so the first characteristic which we are going to discuss now is crest and trough. Alright, crest and trough. As I was using this term in my yesterday's class as well, like mechanical waves travel in the form of crest and trough, and as well as in the compression and rarefaction, like there were two types. All right, so here I am going to make the diagram first. So here is the diagram. Basically this will travel like this. All right, like this. Alright, so here we have some points. Let me mark that with this color so that you people can see. So for suppose I am giving the name which is A to this point, then again this is the B, then again here I am making C, then here again we have D. Alright, so the parts which are on the upper side, like crust is what, let me tell you the definition of the crust was. So crust is a point on a wave that exhibits maximum position. All right, maximum position or upward displacement from undisturbed position. As you can see, this is its undisturbed position. Wait, let me make here with this color. So it's here undisturbed position. So it how it is covering the upward displacement like this, or you can also say it as maximum displacement. All right, and that is a positive too. So this point is what, it is a crust, as well as this is a crust. So let me write these both points as crust. All right, so I should write the definition of the crust here as well. So what is crust? Crust is what? Crust is basically a point. It is basically a point on a wave, that exhibits maximum positive or upward displacement. So here I am writing upward displacement. You can also write maximum positive distance. All right, that is also right. Displacement from undisturbed position. Undisturbed position. So that point is basically what is crust. All right, so as you can see the definition, it is a point on a wave, as we have made this point on the wave that exhibits upward displacement. It is like taking upward displacement from its undisturbed position. As you can see here, it's here undisturbed position, and from there it is taking upward displacement. All right, so that point is known as what? That point is known as crust. All right, so here in this case, what are the crust? A and C are the crust here. So let me write that as well. What are the crust here? Those are A as well as C are crust. Alright. So now we are going towards the trough. Alright. So what is the trough? Trough is a point on a wave that exhibits maximum negative or downward displacement. Alright. That is the opposite of the crust. We'll be talking about that as well. Wait, let me write here the definition first, so that it can be easy for me to explain you guys. Trough is what? Wait, let me write with this white color. So it is a point same on the wave, where on the wave that exhibits maximum negative. There we used maximum positive. Here we are using maximum negative. I'll be telling you negative, or we can also write downward displacement, as we wrote there upward displacement. So here downward displacement. Alright, downward displacement. So I'll explain you guys the trough with the help of this definition. So it is a point on the wave. Alright, of course this would be the point on the wave. Alright, then that exhibits maximum negative, which means it will go down now. When we were talking about maximum positive, so that was going up. Now we are talking about maximum negative, so it will go down. Or we can also write it covers the downward displacement, means it will go down at the maximum point. Alright, wait, let me write here down. Alright, so this is its undisturbed position and it's going down. Alright, down. So what it is covering? It is covering downward displacement, or we can say maximum negative. Here, as you can see, undisturbed position, then covering the displacement of downward. So these points are known as what? These both points are known as trough. Alright, these points are known as trough. So here I can write what points are known as trough. So here point B and D, points B as well as point D are the troughs. Alright, as we have discussed about the crust and trough just now, so now we are going to discuss about the compression and rarefaction, which happened in the longitudinal wave. These happened in the transverse wave. Now we are going to define or discuss the characteristic of the longitudinal wave, that is compression and rarefaction, because they travel in the form of compression and rarefaction. So let me write here the second one. Alright, so second one we do have compression and we do have rarefaction. This is not rarefaction, but instead that is rarefaction. Alright, so compression and rarefaction. So let me make here the diagram first, so that it can be easy for me to explain you guys. Wait, let me make here the diagram first. So here I'll make the dots one. here we have dot dot dot. Wait, let me complete this diagram first, then I'll tell you what I am making basically. I guess this is fine. Alright, for the last one, I should make it a little bit thick. Alright, so as I've made the diagram here, so initially I'm going to write the definition, alright, so that it can be easy for me to explain you guys. So compression, now compression is what? Wait, so compression is a point, wait, let me write here. It is a point where particles of the medium are closer, wait, or the density is maximum. Density is maximum. Okay, so let me tell you about this definition first so that we can understand that. So compression is what? Compression, it is a point, alright? Compression is a point where particles of the medium are closer or the density is maximum. So here as you can see, where the density is higher or maximum, or where the particles are closer. So as you can see here, particles are closer as well as density is maximum. Again, this is not, because particles are not close, alright, not closer. Then again here we do have particles are closer as well as there is a maximum density as well, alright. So here these two parts are known as what? These two parts are known as compression. Alright, so what's the compression? Compression is a point where particles of the medium are closer or the density is maximum, as I have told you here with the with using this diagram. So now let's go towards the second one, which is the rarefaction. Alright, so rarefaction. So what is rarefaction? Not fraction but faction. Let me write here first. So it is a point where the particles of medium are farther apart or density is minimum. Density is minimum. Alright, so now rarefaction is the point where the particles of the medium are farther apart or density is minimum. Alright, in the compression we were talking about maximum density. Now we are talking about the minimum density, and particles are not closer but instead they are farther apart. So as you can see here, we have two regions here again. Here we have one this where the density is minimum, again this one where the density is minimum and the particles are farther apart, again this where the density is minimum and the particles are farther apart. So these three regions are known as what? These three regions are known as rarefaction. So let me write that as well. it is known as rarefaction. Alright, so we have discussed about the crust trough, and we have discussed about the compression and the rarefaction. Now we are going towards our last characteristic. Then again we'll continue our characteristic in the next video as well. So the last characteristic here I want to talk about is the wavelength. Alright, after wavelength I'll end this video here. Then the remaining characteristic we'll be discussing in the next video. So wavelength is generally represented by this sign, and this sign is known as what? This sign is known as lambda. Alright, lambda. This is a Greek letter. Alright, we do have alpha, beta, lambda, gamma. So this lambda is the Greek letter. Alright, and wavelength is represented by that. So let me make here the diagram first, so that it can be easy for me to explain you guys. So here I am making this diagram. Alright, so wait, let me make here the crust first, as we have talked about crust just now. Trough, then we have crust, and then we have trough. And here are one wave completes, and here we have another wave completes. Alright, so this is point A, this I am making point B, then again this is point C, and this is point D. Alright, so it is what? It is simply the length of one complete wave cycle. Alright, wait, let me make here. As you can see, the one wave cycle is completing here and another is completing here. So the length between them, alright, so it is simply the length of one complete wave cycle. So this, as you can see, I have made the length of one complete wave cycle. So this, the length of one complete wave cycle, is what we call the lambda, which is the wavelength. Alright, this is the wavelength. Again, it is the distance from the crust to crust, or from trough to trough. Alright, so let me write this as well. It is the distance from crust to crust, or it can be a distance from trough to trough. So as you can see here, this is the crust of one wave, this is the crust of another wave. So the distance between them, the distance between this crust to crust, is what we call the lambda, which is the wavelength. Again, wavelength. Again, as I told you, this is the distance from the trough to trough as well. So here we have trough to trough. So the distance is what we call the lambda, which is wavelength. So this wavelength can be a length of one complete wave cycle, that is also known as wavelength. Again, this is the distance from crust to crust, that is the wave length. Again, this is the length from trough to trough, that is also a wavelength. So the SI unit of wavelength is what? It is meter. Wait, let me write this here. SI unit of wavelength is meter. Alright, so as we have discussed the three characteristics today, we have discussed about the crust trough, compression, rarefaction, and then wavelength. In the next video, we'll continue our characteristic of the wave, like we do have a lot, so we'll be talking about those as well. So this was all for today.